All right, so with all of the libraries installed, let's go ahead and work in our simple log so we can consolidate the knowledge we've seen in the previous class. The first thing I'm going to do is create uh, a new repo that I'm going to call module 1 basic concepts. You can call whatever you want. It's just for us to keep the structure of the course in here. And then I'm going to cd into this module 1, and I'm also going to create a new repo named scripts. All right, so you can see here on the left, module 1 scripts, and inside scripts, I'm cding into it. I'm going to create a first log.py. All right, so we have our file here, log.py, and then we can start typing here. So, all right, let's go ahead and try to implement our simple log. Okay, so this is going to be a class because we want to explore the concepts of it. So maybe let's add a comment here. So, all right, we're going to implement a simple log. And for sake of simplicity, this is going to be in memory. All right, we're not going to use disk here, save anything to disk. So implement a simple in memory log and append only. That's what I have discussed. All right. So what do we want to do with the simple log? So we need to try to replicate what Kafka does. Inside, we're gonna talk about topics and partitions later, but the first thing we're gonna be able to do is to append information, right? So we have an append only writes. All right, that means that data can only be appended or added to the end of the log. The second thing is immutability, right? We'll look into this in the class. So we want to have immutable records. That means that once added, data is never changed. Okay, and we also want sequential reads. Yeah, so consumers need to read in order. Okay, so this is what we want to implement in our class. Go ahead and import a library named threading, okay? Because this will simulate concurrency. So this will help us illustrate the concept of safety when we're writing to the log. All right, we're going to use this library named threading. Okay, let's define our constructor. First thing, you're going to start this. And what do we want to have here? All right, let's add another comment. We're going to have our records, which will be a list that are going to act as our log segment. Let's use a list for this. Again, in real system, this wouldn't be it wouldn't be persisting in memory. We're going to persist this into disk. And we're going to have a lock, which is of type threading.lock, because we want to ensure that only one write happens at a time. That's the goal of this, okay? So this we're going to simulate how Kafka guarantees order append safely. That's what we're going to do, okay? Let's go ahead and define those. I'm going to have our self.records, as I mentioned, will be a list. Okay, this is going to hold our records. And I also have the self.lock, which is a threading.lock. With this, we want to ensure thread safe writes. All right. After we build the constructor, we can go ahead and define our methods. So the first one, naturally, we have the append. All right. So let's define the def append. We want to append what? We want to append a record of any type, and it's going to return us ending. Okay. So basically, what our function, our method's going to do is to Pardon me. Got it. So what our function is going to do is basically just append a new record at the end of the log. Okay, so the record could be any type of data you want to store. And it's going to return, why an int there? Because it's going to return the offset where the record was added. So we're going to get a record, append it to the end, and I'm going to return the offset just to tell us where it was added, to which position we're talking about. Okay. So let's acquire a lock before we start the writing. So to make sure we only have one write at a time. To do that, we can declare the with statement here. And how do we define the offset? Okay, so imagine that the offset is basically the index position before we add in the record. Do we agree that? So the index position before we add, that's where the offset is located at. Okay, so we can represent the offset as just the length of the records, right? And we can use the inbuilt Python function just to say, all right, for my records, I'm going to just append a record. Okay, so we're going to append to the in-memory list, right? We can do a print statement here. So the record appended, and we assigned the offset, and we can pass here our offset. Okay, return the offset. That's it. That's our append function, right? After that, what we do have here, we want to be able to do reads, right? Let's go ahead and define the read function. We want to have an offset if we want to read from an offset, and it's also going to return that record at that given offset. Okay, so in that case, not int, could be anything. Let's also add a comment here. I am really struggling to get this right. So what does our read function will do? We'll basically read a single record from a specific offset that are going to pass through it. So basically our offset is the record position in the log, and we're going to return the record itself at the given offset. Makes sense? So we have the read function. We want to say, hey, given that log, given that offset, return me the record at that offset. All right, simple. Okay, so we need to just do a quick check, right? Because we want to make sure the user does not tell us an offset that it's out of boundaries, that doesn't exist in our log. So we can do a quick check. So we can say, for example, like if the offset smaller than 0 or the offset is bigger than the length of our records, okay, so basically out of bounds, let's raise an index error. This is going to say offset is out of bounds. All right, and basically let's do a Python notation here to do return our records at the offset position, just like that. Okay, but remember that I told you that in our function, in the logs, one of the characteristics of it is that you can read from any position, starting from any position, right? Not only from any position, but starting from any position. So I can implement that. That's very simple. We can create a function named read from, and we can pass a start offset, which is going to be an int, and that's going to return a list, because in this case now we're not returning a single element, but all of the elements starting from that offset in the list. Okay, so what is this telling us, right? This is going to simulate a consumer that is reading a stream starting from that specific offset. So I say simulate that a consumer is reading the records starting from a specific offset. So our start offset is equal to where the consumer starts reading from. And we're going to return a list, which will be the actual list of records from start offset till the end of the log. All right, makes sense? So again, let's just copy and paste this because this also applies here. We want to make sure that our offset that the user passes is inbounds. So in this case, we do have a start offset. Okay, hope that's clear. And basically, we can use Python slice notation to do our records at starting from the start offset till the end of the list. Simple like this. Okay. What else can we add here? So maybe let's go ahead and try to fetch the index where the newest record is located, because this has some applicability in Kafka. We call it like high watermark. We're gonna go into this later. But basically, let's just get the latest offset. What's the latest offset of our log? This information sometimes is important. It's gonna return an integer, and basically, this returns the latest successfully written offset. Okay, returns an integer representing the last index written, or we're gonna return a -1 if the log is empty. This is just a convention. Okay, in case we don't have anything, so in case our records are empty, so nothing is there, we can just return -1, just like we're saying. Otherwise, just return the length of our records -1, which represents the last valid offset. Okay. All right. I think that's good enough for us. Maybe we can create something to print all of this information. So let's create our rep. I'll return a string. This is just like a visual representation how you want to visually show your print statements for your class. Google it if you're not familiar with that. So let's just get a visual representation of the entire log. Okay, so let's get a representation of our log. What can we do here? Let's first check if the log is empty. If not, our records, we can say log is empty, string type. Or we can create a header, and let's do, okay, log content. Let's skip one line here. Then we can, for each line, we can print what? We can do the offset. Let's call it index. We can also print the record. So at this offset, at this index, that's the record. And for every element in the records. So we can say for every index, let's close this. For every index and record available in our self records. So we have the header, the lines. Maybe we can close it up with a footer. Let's say skip line, end of log. Okay. Now I'm just gonna return the header plus skip line, and let's join all of our lines here for our list, and let's add the footer. All right, that's it. Let's stop here, and next let's just create a simple script so we can visualize if this is working. Okay, see you next.